Hello everyone, in this video we'd like to present our work, Refusion, on a very large-scale realistic image restoration with latent-space diffusion models. Our main contributions are summarized as follows. We present a unit-based latent diffusion model for large-size image restoration. We also propose to change the diffusion-based network from unit to NAF-net. We perform a comprehensive study of cell training strategies to improve the restoration performance, and we evaluate our approach on extensive real-world and synthetic datasets. Our method leverages IRST as the base model for realistic image restoration. Consider the mean reverting ST as equation 1. IRST proves that it has a closed form solution for all times, and the transition color is a Gaussian with mean and variance. Specifically, as t is large enough, the mean would convert to mu, and the variance would convert to lambda. By letting mu be the LQ image and x0 be the HQ image, the above ST would naturally simulate the image degradation process. Iteratively running a diffusion model is notoriously time-consuming. Latent diffusion compresses images and performs diffusion on the latent space, but it requires VE with gain learning, which is unstable and would miss details in the reconstruction. In this work, we propose a unit-based latent diffusion, which has hidden collections from encoder to decoder and uses latent replacing learning strategy. Our model is thus stable in training and traces cross-modality images, and the restored results are also accurate. The latent replacing learning strategy is shown in this figure. We would like to combine LQ hidden collections with HQ latents to generate high-quality images, which could ensure that transforming the latent to HQ space would restore the HQ image accurately. Here is a modified nonlinear activation free block, which embeds the time into the network and the same as other diffusion models. The NAF-net performs better than units while requiring less parameters and floats. We also analyzed 4 training hyperparameters: noise levels, denoising steps, training patch size, and optimizer and scheduler. All results are performed based on the image shadow removal task. In the experiments, we apply our Refusion model on 4 different tasks: image shadow removal, stereo image super resolution, bokeh effect transform, and HR non-homogeneous dehazing. Here are the shadow images and our results, and our method won the 2nd place in the anterior image shadow removal challenge. Here are stereo input images and our results. For the bokeh effect transform task, given the length information, our model can generate the corresponding images. For the dehazing task, the input images are almost 6,000 times 4,000 resolution, which is very difficult to normal diffusion models. We apply our unit-based latent diffusion model on this task and achieve good results. In summary, first, we present a unit-based latent diffusion model for large-scale image restoration. We change the backbone from unit to NAF-net to accelerate the diffusion process. We comprehensively analyze different training strategies to improve the results. We also apply our model on extensive experiments and win the 2nd place in the anterior image shadow removal challenge. You can scan the QR code to access our code and pre-trained models. Thanks for your listening.